Hi guys, in this video I'm going to go over a few example questions of solving simultaneous equations by the elimination method. So we use the elimination method when our two equations that we're trying to solve both have x and y on one side and then a number on the other side. So we see that with both of these equations, neither of them have x or y by itself. That tells us that we want to use the elimination method. The question might not necessarily say use the elimination method or use the substitution method. So we have to decide that. Anyway, so because we have the x's and y's on one side and a number on the other side, what we're going to do to start us off is we're going to write both of the equations on top of each other. So we have 8x plus 2y equals 2, and we have 3x minus 2y equals 9. So we've written them on top of each other so that our x's are lined up, our y's are lined up, our numbers are lined up. So what we can do from here is we want to add or subtract these equations together so that we can eliminate either the x's or the y's. And this is why we call it the elimination method, because we eliminate one of their variables. To do that, first of all, we need to decide which one we want to eliminate. And in this case, we're going to eliminate the y's because the 2's are sitting out in front. So because this is saying positive 2 and this is negative 2, they're the same number, so we know we want to eliminate the y's. Now we need to decide whether we're going to add or subtract. So the way that we decide that is we look at the signs in front of the numbers. So we see that one's a positive and one's a negative, meaning that in this case, I want to add. So we want to add when signs are different. Okay. So what that means, seeing that we've decided that we want to add the equations, we're just going to add along our columns. So we're going to add the x's together first of all. So we have 8x plus 3x equals 11x. And then we have 2y plus negative 2y equals 0. And this is kind of the point for elimination, that the x, it just kind of goes away. So we've eliminated the y's. So we're left with 8x equals, and then 2 plus 9 equals 11, meaning that we now have a new equation of, we'll write it again, 11x equals 11. And we want to solve this equation. So of course, what we need to do is just divide by 11. I get x equals 1. So that's one half of my solution, but of course I now need to find the y value that goes along with it. So what I'm going to now do is take my x value and substitute it into either one of the equations. It doesn't really matter which one you sub it into. So I'm just going to take this over here, and I'm going to sub it into that first equation. So I have 8 times 1 plus 2y equals 2. So I'm substituted into that first equation over here. And now I just need to solve this accordingly. So 8 times 1 is 8. And then next deciding, well, should I get rid of the 8 or the y first? I want to get rid of the 8, so I'm going to subtract by 8 on both sides. So 2y equals negative 6. And then divide by 2, y equals negative 3. So now I have my two solutions, my x and my y. And I may wish to write these as a set of coordinates. So I can therefore the solution is 1, negative 3. We don't necessarily need to write that. Just writing x equals 1, y equals negative 3 is fine enough. So that's a basic process of the elimination method. It's all about lining up the equations, adding or subtracting, and then solving accordingly. So let's just do a few more examples. So let's look at this one. Solve the equations 4x minus 2w equals negative 1 and 7x minus 2w equals 8. So like we saw in the previous question, the first thing we want to do is we want to line up our equations. Negative 1, and then 7x minus 2w equals 8. So we have these two equations. And again, just looking at the into numbers, the two letters, we see that we want to eliminate the w's again because they both have 2 sitting in front of it. Except this time, they're both negative 2. So in the previous question, one was a positive 2 and one was a negative 2. So I added. This time, the signs are the same. So we subtract because the signs are the same. And that's the key thing with the elimination method. You need to check to see, well, the signs are the same, and therefore we want to subtract. If they were different, we want to add. Anyway, continuing on with this, so 4x minus 7x is negative 3x. Negative 2y minus, negative 2w minus negative 2w is 0, so it goes away. We've eliminated it. Again, that's kind of the point. And then negative 1 minus 8 is negative 9, leaving me with the equation negative 3x equals negative 9. And then to get rid of that negative 3 sitting out the front of it, that's obviously saying negative 3 times x, so we're going to divide by negative 3. Negative 9 divided by negative 3 is positive 3. So I get the value x equals 3. Now that I've done that, again, like what we did in the previous question, I'm now going to substitute that into either one of the equations that I had at the top. So I'm just going to choose the first one again, and it doesn't matter which one you do. So I'm going to do 4 and times 3 minus 2w equals negative 1, and then just continue to solve. 12 minus 2w equals negative 1. Then I'm going to subtract the 12 over, so I get negative 2w equals negative 13. And then when I divide them both sides by 2, I get positive 6.5. And it doesn't always need to be an integer answer. Sometimes we are going to get decimals or fractions, and that's totally fine as well. And then, so therefore, my solution you can write again as 3, 6.5. Okay, so we just got our two answers, and we're just, putting that in. So we have we've solved those kinds of questions where we don't need to do any changes to it. Looking at question 3 now, this third example I've got here, we want to solve the equations x plus 2y equals 16 and 2x plus 3y equals 29. So we'll write them down. So we have x plus 2y equals 16, and we have 2x plus 3y equals 29. Now, in the previous examples, we saw straight away that either the x's or the y's lined up perfectly straight away with the numbers. So we saw that in the previous question, the w's had negative 2, so it was 2. And in this other question, the y's both had 2 sitting in front of it. So we could just eliminate things straight away. In this case, though, neither the x's nor the y's are identical just yet, and we need to change that. So what I need to do is decide if I want to eliminate the x's or the y's through multiplication. I need to multiply one of the equations before I can do the elimination. Looking at this, what I want to do is I want to look at the x's, and if I can change that to 2x, I'll then be able to eliminate. The way that I'm going to be able to do that is by multiplying that top equation by 2. So I'm going to multiply that top side by 2. So I'll get 2x, but I can't just multiply the x by 2 and not multiply everything else. So I'm also going to have 4y equals 32. I'm going to keep the bottom the same though, because I don't want to change that. So I have 2x plus 3y equals 29. Now that I've changed one of the equations, the x's now line up perfectly, and I can therefore do my substitution. So we see again, both of these are positive numbers. They're both positive 2, and because the signs are the same, as we saw in the previous question, that means we want to subtract. So we're going to subtract these two things. 2x minus 2x is 0, it goes away. 4y minus 3y is y, and 32 minus 29 is 3. Now, we don't actually need to solve any more equations there because we're told straight away that y equals 3, so we can just kind of write that down. We've already solved half the equation, half the question. So now that we have y equals 3, like what we've done with all the other questions, we're now going to substitute into one of the other equations to find the value of x. So I'm going to use that first equation we have at the top there. So therefore, I have x plus 2 times 3 equals 16. X plus 6 equals 16. X equals 10. And there we go, we have x equals 10. And therefore my solutions, now remembering this time I got 10, x is 10 and y is 3. So I'm going to have 10, 3. Make sure that when you are doing the substitution of the first value you found into the other one, that you're substituting is the right one. So here I found y equals 3, so I needed to replace the y with 3. I don't want to replace the x with 3 because I'm still trying to find what x is. So that's a question where we need to change one of the equations before we need to do the elimination. One last question. So again, let's just line up these two equations. So we have 2x minus 5y equals 22, and 3x minus 2y equals 11. Now looking at this question again, we see that neither the x's are identical and neither of the y's are identical. So we're going to need to do some changing of the equation. The problem is though, is that I can't multiply, like if I wanted to change the x to be 3, like I can't multiply 2 by a number to get 3. Well, I can multiply by 1.5, but that makes it a bit trickier. Similarly here with the y's, there's no number that I can multiply -2 to be -5. So in some cases, what I need to do is I might need to change both of the equations. So just looking at the x's, I can't multiply 2 to be 3, and I can't multiply 3 to be 2. But what I could do is I could multiply the 2 to be 6, and I could multiply the 3 to also be 6. And then, so even though I can't line up the x's to be 3, I could line them up to be 6. So the way I'm going to do that is I'm going to multiply the top equation by 3. That will leave me with 6x minus 15y equals 66. But I'm also going to multiply the bottom equation by 2. So by changing both of the equations, I'm now left with 6x on both of them. Minus 4y equals 22. Make sure that when you're doing this, you're multiplying all the things in the equation, not just one of them. But what I'm showing here is you don't need to multiply by the same number. I multiplied the top equation by 3 and the bottom equation by 2. That achieved me having the x's lining up. And so now I can just do my elimination. Again, both of these x's are positive, 6x. So because the signs are the same, I'm going to subtract. So I have the x's go away. I have negative 15y minus negative 4y. That's going to be negative 11y. Make sure that you're looking out for your negatives here. So the reason why I got this is negative 15y minus negative 4y. Well, you need to remember that two negatives make a positive. So this is basically saying negative 15y plus 4y, which equals negative 11y. So make sure that you're taking care when doing these subtractions, particularly when it comes with negatives. And then with 66 minus 22 equals 44. And then solving this equation, I get y equals negative 4. Now that I have y equals negative 4, like what I've done with all the other questions, I now need to substitute it in, making sure I'm substituting into y, not into x. So therefore, I will have 2x minus 5 times negative 4 equals 22, just substituting in that first equation. I'll get 2x plus 20 equals 22, making sure that we're taking care, we're saying negative 5 times negative 4, so that'll be positive 20. Then, of course, I'm going to subtract the 20, so I get 2x equals 2, and then divide by 2, x equals 1, meaning that my solution can be written as 1, negative 4. So, in this question, you see that, like in some instances, I need to multiply both of the equations before I can do the elimination, and then this isn't particularly important when you're doing subtraction or addition or whatever with the negatives. Make sure that you're doing, like, you're going to get the right answer. If that means having to just use your calculator, putting in negative 15 minus negative 4, giving you negative 11, then do so. Anyway, hopefully these example questions have been useful, and you can use this video to refer back to studying in the future. If you have any more questions about it, feel free to ask. Thank you.